This is a presentation to help you write balanced chemical equations. The best way to do this is by using an example, and that example I'm going to use is going to be a solution of sodium carbonate was titrated with hydrochloric acid. Write a balanced chemical equation for the reaction. So the first thing that I would always advise you do is to write a word equation so you know what the reactants and products are. So the reactants in this example are given in the question, sodium carbonate and hydrochloric acid. And hopefully you can sort out from that the products are going to be sodium chloride, sodium from the sodium carbonate, and the chloric part gives you the chloride from hydrochloric acid, and that the other products are water and carbon dioxide. So step 2 is to use the charges on the ions to work out the formula for each of the chemicals. So we need to know the charges on the ions. It's not as difficult as you might think. Okay, the group numbers from the periodic table give you a lot of information. So group 1 ions have a 1 plus charge, group 2 have a 2 plus charge, group 3 have a 3 plus charge, group 5 have a 3 minus charge, group 6 have a 2 minus charge, and group 7 have a 1 minus charge. If you're not sure where these charges come from, it's best to spend some time revising your ionic bonding. The transition metals, so iron and copper, if you need to know the charges of those, they will give them in Roman numerals. So iron 2 has got a 2 plus charge, iron 3 has got a 3 plus charge. Copper down at the bottom there should have a Roman numeral of 2 to give you a 2 plus charge. The ones that you do have to learn are the ammonium ion. This is made up of a nitrogen and 4 hydrogens, and overall it's got a 1 plus charge. Don't be thinking that it's got a 4 plus charge. The 4 at the bottom is showing that there are 4 hydrogens, not the charge. Okay, so it's a nitrogen, 4 hydrogens, and that all together has got a 1 plus charge. A hydroxide is made up of an oxygen and a hydrogen that's got a 1 minus charge overall. The nitrate is made from a nitrogen and 3 oxygens that all together has got a 1 minus charge. Carbonate, a carbon and 3 oxygens that overall has got a 2 minus charge. And the sulfate, a sulfur and 4 oxygens that all together has got a 2 minus charge. Okay, so we need to use those now to be able to write the chemical formula for each of the bits of the equation. So looking at the sodium carbonate then, the sodium's got a 1 plus charge, whereas the carbonate has got a 2 minus charge. Now overall the formula has to balance in terms of the charge. It can't have a 1 plus or a 1 minus charge. So we need to have 2 of the sodiums to cancel out the 2 minus of the carbonate. So 2 sodium ions, 2 pluses here to cancel out the 2 minus charge here. So that's shown as Na2CO3, 2 sodiums and a carbonate. Hydrochloric acid then, the hydrogen has got a 1 plus charge, the chloride has got a 1 minus charge, so they already balance. So we can just combine the 2 of them together so the charges cancel out. The sodium chloride, the sodium ion has got a 1 plus charge, the chloride ion's got a 1 minus charge, so they will cancel out the 1-to-1 ratio, so NaCl. Then hopefully by now you know that water's got a formula of H2O and carbon dioxide of CO2. So the final step is to balance both sides of the arrow in terms of the number of atoms that are there. So this is using your big numbers. So over here we've got sodium, we've got 2 atoms of sodium, but we're only forming 1 in the products. So that's not possible. I can't make the sodium atom disappear. That means I must be making 2 lots of sodium chloride for every sodium carbonate. So put a big 2 in front of the sodium chloride. That now gives me 2 chlorines here, and I've only got 1 over here. So I need to put a big 2 in front of the hydrochloric acid. That means now I've got 2 hydrogens, and that balances out over here my 2 hydrogens. Everything else then balances out. I've got 1 carbon here, 1 carbon there, 3 oxygens here, 1 plus 2 makes 3 on the right hand side. So that is now our balanced chemical equation. So you try these next 2 examples. Pause the video and then look at the answer, which is coming in a second. Okay, so here's the answer. Lithium is added to water. So these are our 2 reactants. It says there's a lot of fizzing, so gas must be given off, and an alkaline solution is made. Hopefully you know from your group 1 metal reactions that lithium plus water makes lithium hydroxide. That's our alkaline solution. And the fizzing is hydrogen gas. If you didn't know that, you need to go back and revise your group 1 metal reactions. Okay, here are the ions that you need to be able to complete this. So lithium hydroxide is made from lithium and hydroxide ions, so Li plus and an OH minus. So our lithium hydroxide is going to be LiOH. They balance already, 1 plus, 1 minus. Everything else is just in terms of their molecules. So lithium is just an atom, it's an element, so it's just Li, that's it. Water, you should know, is H2O, and hopefully you know hydrogen is H2. Again, if you're not sure on this H2, then that comes from covalent bonding in C5 units. So let's balance this then. So the thing that doesn't balance at the moment is the hydrogen. So I've got 1 here and 2 here, making 3. So over this side, I'm going to need some more hydrogens. If I double my water, that gives me 4 hydrogens. Still doesn't equal 3, but if I double my lithium hydroxide, that gives me 2 hydrogens here, plus 2 makes my 4 that I've got over here. I've got 2 oxygens here now, so 2 oxygens here, that balances. But I've now got 2 lithiums, so I need to put a 2 in front of the Li as well. That is now my balanced chemical equation. Here comes another. Pause the video, write out your answer. The answer's coming in a second. Okay, so the word equation then, iron oxide is given here. That's reacted with some carbon, so iron oxide plus carbon. Says the iron is extracted, so that's one of my products, and another product is the waste gas of carbon dioxide. So that's my word equation. Now we need to use the ions to be able to work out the formulae. So iron 3 is a 3 plus. Oxide is in group 6, so it's got a 2 minus charge. So to work out the iron oxide formula, I'm going to need to balance the charges. So I can't just multiply one of them by something, I'm going to have to multiply them both by something. And the smallest number that they'll both divide into is 6, so we'll go for that. So I want to make this side 6 plus, so I times it by 2, and I've got a 6 plus charge. If I times the oxide by 3, I get a 6 minus, so my 6 plus and my 6 minus will then cancel, and I get Fe2O3. Carbon's an element, so it's just C by itself. Iron's an element, it's just Fe by itself, and hopefully you know carbon dioxide, CO2. Now we need to balance the equation as a whole. Okay, so the first thing I would look at here would be my oxygens. I've got 3 oxygens over here, and I've only got 2 over here, so I need to balance these out. This is going to be a bit challenging, but if I times the carbon dioxide by 3, that's going to give me 6 oxygens here. So I'm going to have to times the iron oxide by 2 to give me my 6 oxygens over here. So we've now got 6 oxygens on the left and 6 on the right. Okay, so to balance out the 3 carbons, I'm going to need 3 carbons here. And my ions overall, I've got 2 times 2 gives me 4 ions there. That is now my balanced chemical equation.